Good morning, Algebra kids. Let's go ahead. You guys made it. You're down to your final lesson of Chapter 10. This was actually a relatively short chapter. Only 4 lessons in it that we needed to cover to have you prepared for next year. So you made it. We finished the chapter up, and hey, we did it on the last official learning day of school. So I hope you guys have enjoyed your 8th grade year. I know it wasn't the way that you probably thought it would be, and I really hate to see it come to an end like this, but I have really enjoyed having each and every one of you this year. With that being said, let's go ahead and let's get started with our lesson today. It is Chapter 10, Lesson 4, and we're going to be looking at some radical equations. And in my opinion, guys, we've saved kind of the easiest lesson for last. So I hope you enjoy this, and let's get started. So, number 1, we've got the square root of x plus 7 equals 16. And something I want you to be mindful of as we go through these problems is pay attention to the square root symbol or the radical, and notice how it stops just on the x. It does not apply to this plus 7, and it also does not apply to the 16. So really be mindful as to what the radical is covering. Now with this problem, just like any other problem that has x in it, I want to know what x equals. So we are going to solve for x. And anytime we solve for x, the first step that we do is we get x by itself. So I need to take this plus 7 and I need to move it to the other side. So if I have a plus 7, the opposite of that would be to subtract 7. I know this is probably real basic, and that's good. So square root of x is equal to 16 minus 7 is going to be equal to 9. Now I'm looking for what x is equal to, not what square root of x is equal to. How do we get rid of a radical? How do we get rid of a square root? Think about what is the opposite of a square root. The opposite of a square root is to square something. So I'm going to square both sides. So by doing so, that cancels out the square root symbol. And I'm left with just x on the left. So x is going to be equal to 9 squared, which is 81. And guys, that's really kind of just the general concept of this lesson. So if number 1 came easy to you, then I think this will probably be a pretty easy lesson overall. Let's look at number 2. I've got the square root of x minus 5 equals negative 2. Again, I'm looking to get x by itself. So my first step needs to get that negative 5 to the other side. So I'm going to add 5 to both sides, and that's going to make this radical square root x is equal to negative 2 plus 5, and that's going to be equal to positive 3. Same thing on this one, guys. I want to get rid of the square root symbol. How do I get rid of square root? I square it. Those two cancel one another out. So I'm going to square both sides. Don't forget to square the right side. I know you're going to square the left because you're trying to get rid of the square root symbol. Don't forget about the 3. It needs to be squared as well. So there we have it. X is equal to 3 squared, which is 9. So my final answer on number 2, x equals 9. Not too difficult. Let's look at one more problem that's very similar to those. We have 3 is equal to 2 times the square root of x divided by 3.3. Now this time, guys, notice x divided by 3.3, that fraction, that whole thing is underneath the square root symbol. So that whole entire fraction has the radical being applied to it. Now, if I had wrote square root of x over 3.3, that is completely different. And that's different because the radical or square root only is being applied to the x. Whereas in our problem, it's being applied to that entire fraction. So always pay attention to the radical. Now, again, I want to get x by itself. So I'm trying to get everything to the other side. So the first thing that I'm going to move is the 2. Now, 2 is being multiplied by my radical. So the opposite of multiplication is division. So I'm going to divide each side by 2. From there, I have 3 divided by 2. So when I do 3 divided by 2, I get 1.5, or if you want to leave it as 3 halves, that works as well. And that is equal to, now I still have this square root of x over 3.3. And guys, now this problem is very similar to what we have up top. I've got a number equal to the square root of something. Square both sides. Get rid of that square root symbol now. So I'm going to square both sides. So 1.5 squared. That's going to make it 2.25 is equal to, now I'm not going to square this 3.3, and that's because the square root symbol was applied to that entire fraction. So by squaring that side, I'm simply getting rid of that square root symbol, and I'm left with this equals x over 3.3. Final step, x by itself, I'm dividing, so I need to multiply by 3.3 on both sides. And when I multiply by 3.3 on both sides, x is equal to 7.425. I'm sure a lot of us probably had to use our calculator on that one. So again, if you come over here, 2.25 times 3.3, 7.425. So there you have it. So for number 3, x is equal to 7.425. A little longer of a decimal with that problem. How could we check it? Excuse me. So we have problems 1, 2, and 3. How could we check those to make sure that those answers are correct? Well, take what x is equal to, plug them in. I'm going to take number 1, for example. That one's going to be the easiest one to show you. If I take 81 and I plug it in for x, I'm looking at now the square root of 81 plus 7 equals 16. Again, I just took what I found x was equal to, and I put it where I saw an x. So now I solve. Well, what's the square root of 81? The square root of 81 is 9. So 9 plus 7 equals 16. 9 plus 7, 16 equals 16. So is the answer x equals 81? Absolutely. And that's because 16 is in fact equal to 16. All right, let's move ahead. We don't have too many more problems. Kind of a shorter lesson today. Number 4. So this time, guys, I've got 2 square root symbols. I've got the radical sign, and then underneath of it, it's this whole expression, 5t minus 11, and that's equal to the square root of t plus 5. Now, I've got a square root symbol on both sides. If that's the case, get rid of them right off the bat. And how can I do such? Square both sides. As long as you're doing the same thing to both sides, you can do this every single time. But you've got to make sure you're squaring both sides. They cancel each other out. So I'm left with now 5t minus 11 equals t plus 5. And now this just becomes, guys, I'm solving for t. So let's get my t's on the same side. So I'm going to subtract t. So 4t minus 11 equals 5. And now I need to get my whole numbers on the same side. So plus 11 plus 11. So 4t is equal to 16. Final step, get t by itself, divide by 4. 16 divided by 4, t is equal to 4. So there you have it. So anytime you got a square root symbol on both sides, square both sides, and then just solve. Solve for that variable. All right, I got 3 more examples for you, and then we're going to wrap it up. These next 2 problems are ones that I want to kind of focus on the most. And that's because we kind of get back into that factoring step with this problem. So for number 5, I've got n equals the square root of n plus 12. Now, I'm solving for n. Again, if you see a variable, we're solving for it. That's what this whole entire lesson is. I'm taking that letter and I'm solving to find what it equals. So I want to find what n is equal to. Now, traditionally, guys, we've been moving stuff over and combining things when we can. On number 5, there's nothing that I can move right now. I'm not going to subtract this entire thing because it really doesn't do anything. What I want to do first is I want to get rid of my square root symbol here, that radical. And the only way to get rid of it is by squaring it. So I'm going to square the entire right side. By doing such, it's going to eliminate the radical. It's also going to cancel out that squared. Because I squared the right, I also need to square the left. So my new equation is n squared is equal to n plus 12. Now, if I take this equal sign out, this looks like a trinomial. N squared, n plus 12. I need to get all of this to the same side. So to get n to the other side, I'm going to do the opposite. It's positive, so I'm going to subtract it over. So minus n minus n. So n squared minus n equals 12. Now let's focus on getting the 12 over. I've got to subtract it as well. So my new equation is now n squared minus n minus 12. And that's all equal to, because we got rid of everything on the right, it's equal to 0. Because it's equal to 0, we can go through and we can factor this trinomial. So let's go ahead and let's factor it out, and let's see how many, we'll see what we can find for n. Now, because n is squared, off the bat, you should already know how many answers you should get. And the answer is you should have 2 answers here. So let's go ahead and let's factor it. 2 sets of parentheses, n squared. The only way to create n squared is with n and an n. Now, I've got to multiply 2 things to get a subtraction symbol. The only way I get a negative is with a positive and a negative. So I know my 2 signs are going to have to be one positive and one negative. Now I'm looking for 2 numbers that multiply to get 12, add together to get negative 1. And once you go through and you kind of guess and check a little bit here, it's actually going to come out to n plus 3 and n minus 4. So there is my factoring of that trinomial. Final step here, because I'm trying to find n. Both of these are equal to 0. So I have n plus 3 equals 0. I also have n minus 4 equals 0. Find n. So I subtract 3. N is equal to negative 3. I add 4. So add 4 to both sides. N is equal to positive 4. So I actually have 2 answers here. Now, you're going to find 2 answers because n is squared. So you should have 2 things that n is equal to. Now, the problem is only one of them is going to work. I cannot put both of these back into my original equation for n and they both be true. Only one thing can go back into n because remember, in that original problem, n was not squared. N was just a regular n. We created it squared by getting rid of the square root symbol. So because I have just a regular n cannot be both negative 3 and 4. So I need to figure out which one of these answers makes sense. I'm going to go ahead and I'm going to scratch out number 6. We'll move that to the other page. So I want to figure out which one of these makes sense. And the way to do that is take what n equals, your 2 solutions that you found, and we're going to plug them back in. So, and I'm going to plug them back into the original problem. So when I plug them back in, I have negative 3 is equal to the square root of negative 3 plus 12. And now I'm going to solve, and I'm going to find out if they equal one another. So negative 3 is equal to the square root. Negative 3 plus 12 is going to be equal to 9. Square root of 9 is 3. So is 3 equal to negative 3? The answer is no. Now, just because I found that -3 did not work does not mean I'm just going to, excuse me, does not mean I'm just going to assume that n equals 4 is the one thing that n is equal to. Plug it in, make sure it works. You may have factored completely wrong here, and maybe neither of them work. So plug them in. 4 is equal to square root of 4 plus 12. Solve. 4 is equal to square root of 16. 16, the square root of 16 is 4, so 4 is equal to 4. That is true. That works. So the only thing n could be is 4. And we found so because when we plugged -3 in, it did not work. So again, when you do square and you end up having to factor, you are going to get two things for n. And that is because, and you should, because you have squared n. You have made it now into a trinomial where it creates a parabola and it's going to cross through the x-axis at two different spots. That's where this -3 and this 4 come into play. But in our original equation, n is not squared, so therefore you should only have one number that n is equal to. So I need to plug both these back in, which we just did, find out which one is equal, and that then is my solution. So a little bit of extra work on these. However, it's nothing that we have not done. You guys have factored. You guys can plug a number into an equation and solve. This is nothing new. The only new concept is how I got to my factoring. I had to square both sides and then move all those pieces over to create that trinomial. All right, so we've looked at a couple different examples now. Let's look at our final problem. All right, so our last problem, number 7 here, we've got the square root of 3y plus 8 equals 2. And you're going to have some examples that look like this. And I think you'll have a good idea on what I mean by that when we get to the final answer. So just like we've been doing on our previous problems, we're going to solve for the variable. Now our variable here happens to be y, and I want to get y by itself. So the first thing I need to do is I need to move that 8. And to do so, I'm going to subtract 8 on both sides. So the square root of 3y is equal to 2 minus 8 negative 6. All right, next, just like we've been doing, I can't do anything else because I got that square root symbol in the way. I've got that radical just right in the way. How do I get rid of it? Square both sides. Okay, so let's square both sides. The radical and the squared symbol, they cancel one another out. So I have 3y is equal to negative 6 squared. Well, what's negative 6 times negative 6? That's going to give you 36. Now what? Divide by 3. So when I divide by 3, y is equal to 36 divided by 3. It's going to give you 8, or excuse me, it's going to give you 12. So y is equal to 12. Now, this is why, guys, on every one of these problems, very important that you go back through your work and you check it. Because, hey, we just got the answer y equals 12. Done, right? Think again. Plug it back in. 3 times 12, all underneath the square root symbol, plus 8 equals 2. Solve. Okay? Simple enough. I want to simplify the left side first because the right side's already done, and it's 2. 12 times 3, we just did that. That's 36. So 36 square root plus 8 equals 2. Okay? Pretty easy. Square root of 36 is 6. 6 plus 8 is equal to 2. Wait a minute. 6 plus 8 is 14. 14 does not equal 2. I don't know in what universe it does, but it does not in ours equal 2. That would be considered, guys, a no solution. When you get an answer, you plug it back in and then you check it, and it comes out where they're not equal. The sides don't match. That's going to create a no solution situation. So the answer to number 7 is going to be no solution. It's very important, guys, when you go through and you solve these, that you throw them back in and you check them. Now, if you've watched this video all the way through, you should have noticed, guys, after the first 3 problems, I showed you an example of plugging it back in and checking. I didn't show you that example just because, okay? I did it because instances like these, it's possible. You might get a variable equals something, but that's not the case. It is really no solution. It might come out to something, but that's not the correct answer. So it's always important. Plug your work back in, check them. This took us 30 seconds to do. If you go through this video and you watch when I started this check process and when I finished, probably was less than 30 seconds even. It won't take you long. Guys, it's been a pleasure all year long. First and foremost, I want to say congratulations on a tremendous 8th grade year and a tremendous career at Westside Catholic. Best of luck in the future in high school. Every single one of you is going to go on and do big and bright things. I cannot thank you enough for making this year great for myself and welcoming me with open arms at your school at Westside Catholic. If you guys need any help or anything down the road, I'm just a phone call, email away. Reach out. Let me hear from you. Let me know how Mater Dei is treating you. When you get to Mater Dei, say hello to Mr. Keith for me. He taught me, and he probably taught some of your parents, and he might have even taught some of your grandparents. So enjoy Mater Dei, guys. High school is some of the best times of your lives. And from there, I'm out. Have a good night, guys.